Alright guys. Whoa. Oh, shice. Stick that down. Let's take a look here. I like this, once it clicks in your head, the correct way to look at these questions, it's there. It's nice. It's one of those click moments where you're like, oh, I got it. It's just when that click happens. So here, this is all about -4. Sorry, I kind of bled in with the arrow, but I think you guys can see it's all about -4. So as I approach -4 from the left, my outputs seem to be getting closer and closer to 2. So for this input, the output, this input, the output seem to be getting closer to 2. Is that cool with everybody? Now, on the other side, same thing's happening, isn't it? As I approach it from the right, the output seems to be getting closer and closer to 2. So what's the limit, period, at -4? 2. Again, the limit never gets to the x value it's investigating. It never gets there because there might be a problem there. This is how we built a limit. It doesn't matter if there's an open circle there or whatever the hell's there. It doesn't matter. So this limit is 2, but what is f of -4? Undefined. Oh, shice. There's the word undefined. Believe it or not. That's the word undefined. Big old comment tail on it. Yes?
On a test, would you accept DNE?
Yeah. In fact, I think the book does not exist for that, but technically that's really, the word undefined is for that situation, but DNE's fine, it's the idea. DNE is sort of, to me at least, reserved for the limits. Yeah, but again, I think the book uses it, so I'm just one math guy. Now at 1, weird-ass things are happening, right? So as I approach 1 from the left, the output seems to be getting closer to 4. As I approach 1 from the right, the output seems to be getting closer to -2. All right, check. Circle. So what is the limit as x goes to 1, period? Yes, does not exist. They don't agree. So where's the place we both are? That place does not exist because we're in 2 different places. Oh, shit. But what is f of 1? 4. Good, because that's where the closed circle is. So this question and these questions are unrelated. I like it. I really want that distinction made. That's why we created this. It can't be the same as this, or else why the shit would we created? All right, now what about 6? If you look at 6, the only weird thing about 6, it's exactly the same as this, but there is a function value in 6, right? So as I approach from below, it looks like the outputs are approaching 5. As I approach from above, 5. So the limit is 5, but what is the function value at 6? 2, because that's where the actual point is. So can you see that distinction now? F of, that cares all about what's happening there. Limit as, that doesn't give a shit what's happening there. Just what's it look like it's doing. It's a good tool that we created to investigate weird places. Now I want to show you something. Who's got my copy? Let me take it back. I want to show you something. Let me show you something. Whoever got a calculator, you got it. Probably can do this. You put this function in. Got it. Tangent of x minus pi. Yeah, they eat pi divided by x minus pi. You got a really kick-ass table functionality. You go to your table. I've already got my table frequently set up. But see right here, your table set? Second window gets you the table set. And if you tell it your independent variable, ask me what it is. You create your own table of values then. So it's like you're making the calculator make a specific XY table. So here I can, oh, don't graph the damn thing. Stop. Stop. Okay. So here I can tell it, so what do I want? I want 3, 3.1, 3.13. See how it's telling me? Ooh, unfortunately here, but it's got a little bit of a problem. 3.141, 3.142. This is a good place to start, but what's kind of wrong with what it's telling me?
It's not rounding.
It's rounding too much. Kind of gives you the answer, sort of, but if I'm like round to 6 decimal places at least in your word, I don't know, 8 maybe for this one, then this is not going to be good enough. But sometimes you can make your own table and you've got enough definition here, you can see. You can just copy it straight out of there. All right, guys? It's good to know everything your calculator can do. I like it. Now, unfortunately, you can't use a phone on anything. There is a really kick-ass thing called Desmos. You don't know about it? So Desmos.com, and Desmos has an app you can download on your phone. Desmos is a very powerful graphing tool. If anybody here has to go to Calc 3 eventually? One of my students a few years back made a program called Plot.Ninja, and it's the best thing I've ever seen about graphing 3D objects. You can rotate them and shit. So you might want to just go ahead and play with that right now. If you don't have to take Calc 3, maybe you don't want to. It's still kind of neat. Anyway. So you come back out and you do your tangent of the stuff that wasn't specific enough, like 3.13. So I get 1.0000.
Zero, zero.
44799. Now, there's also this little thing you could do. You could, I saw somebody else doing this. 3.141 store in x, and then you can just put tangent of x minus pi divided by x minus pi. And then you can just change x. So now I want 3.142 to be an x. And then you go back up and you say, do that again now. I mean, there's all kinds of little ways so that you don't have to type as much in your calculator. You guys semi with me? So what'd you get as an answer for this? Let me just catch the chase. What's it look like it is? Yeah, if you do all this, it looks like it should be going to 1. Now, could the answer be 1.002? But if you get 1 from the values I gave you, that's fine. If you do something by hand, sometimes you're going to be off. Because we are not computers. Like that. Or, organic computers. But we're not as good as these guys. How are we doing so far? Is this so far good? Yes? Yes. Oh, that's fine. Because I didn't say anything specific about how many decimal places, so you're good. I like it. Alright, now these, I was hoping you would remember, we did something like this, and this is related to that warm-ups number 1 question. What can you, and I'm telling you what to do. Now tell me this, before you just, when you plug a 3 in, you get an answer. No, you get what? 0 over 0, not undefined. Indeterminate. You want undefined. So watch, real quick. You're like, what the shit, Jeff? I don't want undefined. What is the limit as x goes to 1 of this? Get over there. Let me do this instead. Yeah. What's the limit as x goes to 1 of that? Do you have to do any real work? What do you get when you put a 1 in there? 1 over 0, which means it's going to what? Do you guys know what that is? As I put x values really close to 1, I get 1 divided by remarkably small. So it's going to something remarkably big. So that is okay. I really want this. You guys get me? If I let x get close to 1, like 0.9, 0.99, 0.999, it's 1 over 0.01, 0.001, 0.0001. The outputs are getting stupid big. So the answer is no. Done. I got nothing else to do. You want undefined. What that really means is you know the answer. This problem is indeterminate at 3. I love that word. Can you determine the answer for this? Not at the moment, because it's in the freaking terminant, right? You guys with me? That's why we use that word. Can you determine the answer? It's indeterminate. Shit. So what do? I try to simplify first. See if I can eliminate the problem. So if you factor all the way, you can see what makes it 0 over 0 is these stupid things. So get rid of those stupid things, right? And now what do you get when you plug a 3 in? 4 times 6, 24. Yes, yes? We did one just like that before. And then this one I'm going to multiply top and bottom by 3 plus. And again, before you do that, of course, you make sure that it's actually determinate, and you get 0 over 0. You guys see that? So then I do need to do something. So on top I get 9 minus, that's a big place where you can make a mistake. Square root of x plus 9 times square root of x plus 9 is x plus 9, and you subtract that from 9. That. If you left your parentheses off, you might have gotten something really freaky. All over 2x times 3 plus rad x plus 9. So I get, it's cool, the 9's go away. The x's cancel here, so I get negative 1 over twice 3 plus square root of x plus 9. Is that? Oh God, if I could write, your life would be so much easier. Is that cool? On the top I'm going to get an x, on the bottom I got an x, they die. See how that's the problem? That's why I got 0 over 0, so when I eliminate them, I'm not going to get 0 over 0 anymore. What do I get when I plug a 0 in? 3 plus 3 times 2. Yep, make it 112. Let me stop here for a second. There are main kind of ideas for algebraically determining limits. Factoring is an obvious one, because that's a very direct destroy the problem. What's making them zeros? Kill that. Oh, now I can do shit. The second one is actually the same idea, believe it or not, but it doesn't look like it. But it's a conjugate. If you have a radical expression in your limit, and you're getting 0 over 0, you conjugate, multiply by the conjugate, and hope to God things simplify. What about that last one? What can I do with this thing? Can I just cancel out the 2x minus 4? No, because the top does not have 2x minus 4 anyway. Right? So on the top, what do I do? Yes. So it'll be 4 minus 2x over 2x minus 4. You do that, or let's see what it is. It'll be, if you multiply this one by 2, so it'll be 2 minus, and multiply this one by x. So it'll be 2 minus x over 8x. Yeah, they're 8. 4x. Over 2x minus 4. Maybe we should do that one in the back. So let me do this one here. Limit as x goes to 2. 1 over 2x minus 1 over 4 over 2x minus 4. So if I multiply this one by 2 on the top and bottom, multiply this one by x on the top and bottom. Now, there are other ways to do this problem, by the way, if you did it a different way. So here I'm going to get 2 minus x over 4x over 2x minus 4. Is that cool so far? You might have done it in a slightly different way. But now what the hell do I do from here? Now if I plug in 2, I still get 0 over 0. Right? I haven't really eliminated anything yet. You guys see, let me just do this. Let's see if you guys get this. Those are the same thing. 2 minus x is being divided by 4x and being divided by 2x minus 4. How you divide fractions, you multiply by the reciprocal. So then don't you end up here? Does anything factor? Now. 2 minus x, and on the bottom I can take a negative 2 out of this, so it's 2 minus x. Right, if I take a negative 2 out of this, that becomes negative 8, and that becomes positive 2 minus x. Is that decent? Are you guys? Is that cool? Or understood? Kill the problem. Can I put a 2 in now? And you get negative 1, 16. Shit. Not a difficult problem. You simplify it first if it's indeterminate. If it's not indeterminate, that must mean you can determine the answer. Why would you do anything? So don't just start doing shit. Sometimes I give you a problem where if you plug a 2 in, it works beautifully. But people start multiplying by conjugates and like, you did way too much work. You didn't have to do that. It wasn't indeterminate to start with. Are you guys? I call this my hopeful side sheet. Yes?
Why did the 4x turn into a negative 8x?
Why did the 2x minus 4 become a 2 minus x? That's even a better question. So from here I took a negative 2 out. Plop. And so I was left with positive 2 minus x. And what told me to do that? Well, because I saw that. And I want to kill him if I can. You see how a common thread is find a way to cancel the problem. If you can cancel the problem, you ain't got no problem. Except grammar. Okay. Any questions on that? Or any other ones? Any questions on any of these? So, what I think we're going to do, we got a decent ways. The next section after 2-3 gets really weird. And you're not going to want to hear me say it. It's too bad. A lot of my colleagues skipped section 2-4. And as we get into it, you're like, why the hell did I take somebody else? I have a reason for going. There's a reason it exists. 2-4 is a very baby step into the idea of proofs. And the idea of 2-4 is used in a couple places later to explain why major things work. So to me, it's kind of like, why would you skip 2-4 when it explains future things and when it's a baby step into proofs? So if you hate the fact that I do 2-4, I'm fine with that because things you need sometimes are painful. So let's do it. But that means that right here is a decent place to stop. We are going to take a real quick field trip. It's going to be very quick, so don't freak out. If you guys want to pack up, take all your stuff with you because I can't lock the doors. If you want to head out the door, start going this way very slowly towards the tech mall, or wait until I run out in front of you. Okay? If you have to talk to me about something, just wait till the tour's over and walk back to my office with me.